Hello, this video will cover section 1.4 factoring, and this video is intended for students who are taking Math 0305 and as a core requisite with Math 1324. Also to anyone who wants to review a little bit of factoring. So we're going to start with fill in the blank. We have our first statement, the process of writing a polynomial as a product. It's called factoring. And a polynomial is completely factor when each of its factors is, I'm going to be honest with you, I am not sure if the word they're looking for is simplified. So you might want to check with your instructor if you are taking 0305. That one sounds good to me, but I am not sure. Then we have, as you may know, there are many ways to factor. And so the purpose of this lesson is to review or learn different strategies for factoring. We're going to start with the basic concepts from prime factorization, then we will build up to greatest common factor, and then we will end up factoring polynomials. So we're going to start with just factoring a number such as 18. And just to clarify, let's go over this first statement. So, for example, the number 2 and 3 are factors of 6 because if you multiply 2 times 3, you get 6. So let's answer the question, are there any other factors of 6? The answer is yes. We could say 1 multiplied by 6. That will also give us 6. So 1 and 6 are also factors of number 6. Let's move on to our first example here, and we're going to find all the factors of 18. So we could start, I like to start from the smallest factor, that will be 1. So you multiply 1 times 18, that will give you 18. Also, 18 could be divided by 2, so that tells me that 2 is another factor. 2 multiplied by 9 will also give me 18. Another one will be 3. 3 times 6 is also 18. After that, if we continue with the pattern 1, 2, and 3, the next number to check will be 4, but 18 cannot be divided by 4 and get an integer out of it, so 4 is not a factor. 5 is also not a factor because the number doesn't end with a 0 or with a 5. And 6, which will be the next number, we already have it here. And then the numbers just repeat, and so that tells me those are the only factors that I have. Although if you're not sure, you could always use your calculator to check. So I like to list my factors in this order. So I always write the small number and then the large number. And I try to do that because it helps me when I have to factor trinomials, for example, which we're going to do shortly. So just try to get used to that. Now, let's find the factors of the number 24. And so I'm going to start with the number 1 times 24, because the product of those two numbers is 24. Then I could say 2 times 12, also 3 times 8, and we also have 4 times 6. The next number to check will be 5, but 24 is not divisible by 5, so the next one to check will be 6, which we already have here, then 8, then 12, then 24. So, and again, you could see that I listed my small factor and my large factor from left to right. So now we're going to use those same two numbers, and we already have all the factors for number 18 and all the factors for 24. So for example 3, the question is asking us to list the common factors of 18 and 24. So let's do that. So for the number 18, we had just listing the factors, 1, 2, 3, 6, 9, and 18. Now let's move on to 24. And the factors of 24 could be 1, 2, 3, 4, 6, 8, 12, and 24. Now, this part of the question, what is the greatest common factor? And for that greatest common factor, we're going to refer to it as the GCF. And we could see that both numbers, 18 and 24, have several common factors. For instance, they have 1, they also have 2 in common, they also have 3, and they also have 6. Now, to answer this question, which one is the greatest of those common factors, that would be 6. So we could say that the GCF between the numbers 18 and 24 is equal to 6, because that is the greatest, the biggest of all the factors that they have in common. Now, the next statement says the greatest common factor, or GCF, is the greatest factor that divides two numbers. So it has to be common for both. And of course, always you want to factor out the largest number possible. So some steps to find the GCF include listing the prime factors of each number and then identify the greatest common factor. So we're going to do some examples of that next. Example 4, find the greatest common factor of this list of numbers. So what I like to do here is use prime factorization. And just to make sure that you understand, what we're going to use to factor will only be prime numbers. Now I'm going to write the prime numbers from small to largest, not all of them, because that will take me forever, or is probably just impossible. But the smallest prime number is 2, then 3. And these are numbers that can only be divided by themselves and number 1. By the way, 1 is not a prime number, and that is just because the definition of it, the number must be greater than 1. So we start with 2, 3, 4 is not prime because it could be divided by 2. But then we move on to 5, then 7. 8 is obviously not, 9 is not, 10 not, 11 it is, also 13, 17, 19, and I'm going to stop there, but just keep in mind that this list of numbers, it goes on and on. So we start by factoring 14, and what I like to do is kind of like a vertical division. So we could divide 14, could divide it by 2 because it's an even number, and that will give us 7. So 14 divided by 2 equals 7. Now 7 is a prime number, so it could only be divided by 7. So 7 divided by 7 is equal to 1. Now I'm going to move on to the next number, which is 21. And 21 could be divided by 3. That will give me 7. And 7 can only be divided by 7. And that will give me 1. So for my third number, 28, I could divide 28 by 2. I will get 14. I could divide 14 by 2, and I will get 7. And 7 can only be divided by 7, or 1, of course, and that will give us 1. So now we could say that for each number, and now I'm going to write the prime factorization horizontally, so it will look like this. 14 is the product of 2 times 7. 21 is the product of 3 times 7. And 28 is the product of 2 times 2 times 7. Or we could also say 2 squared times 7. But what matters from here is that the only factor, well, we could say that 14 and 28 have 2 in common. However, 21 does not have 2. So for all three numbers, 2 is not even a common factor. But even if it was, remember, we always want to find the greatest, the largest common factor. But in this case, the only common factor will be 7. Because for it to be a common factor, all three numbers, 14, 21, and 28, have to have the same number as the common factor. And of course, we always try to pick the largest of all. Now, let's try to do the same for the next set of numbers, 12, 13, and 15. So the prime factorization of 12, we could divide by 2, we will get 6. And I know 6 could be divided by 6, but we want to use numbers that belong to the set of prime numbers. So we could say we could divide again by 2. We will get a 3, and 3 is prime, so we can only divide by 3, and that will give us a 1. Now for 13, 13 is a prime number itself. So 13 can only be divided by 13 or by 1. And finally, we have 15. 15 could be divided by 3, we get 5, and 5 is also prime, so we divide by 5 and we get 1. Now, if I was to list the prime factorization of each number, you could see it becomes pretty obvious that they don't have a factor in common. And part of the reason is that 13 is also part of those three numbers, and 13 is prime. So if the question had only included 12 and 15, then the answer would have been their greatest common factor is 3, because 3 appears in both. But our question included the number 13, and so 13 doesn't have anything in common with 12 and 15. So then we say that the greatest common factor between these numbers is 1. So you could think of, for example, when we have a number or a variable multiplying something inside the parentheses, we say we need to distribute that number or that variable. So factoring will be the reverse process, or you can think of it as going in the reverse direction. And I also like to remind my students that if they cannot factor in their head, there's nothing wrong with writing it down as a division. And yeah, factoring is the reverse of multiplication or distributing something. So we could think of factoring as dividing as well. And that is very helpful. Factoring is important for many reasons, but one of those is solutions. We could find solutions of a polynomial function. Remember solutions, we also call them zeros, x-intercepts, if those solutions are real numbers, or roots of the polynomial function. And I mean, you could also, they're also very, factoring is very helpful to reduce expressions, not just algebraic, but also trigonometric expressions. And yeah, factoring could help you solve many problems, not only in this class, but also in calculus. So let's move on to example 6. And for example 6, we do have some polynomials. Our first step is to factor out any greatest common factor if this is different than 1. So in this case, example 6, part A, you could see 8 and 4 can both be divided by 2. So I could factor 2. However, that is not the greatest common factor. The greatest is 4. So if I factor out a 4, we will think of this as taking 8x and divide by 4. And so that will give me 2x. So that is what goes here. Then our next number is a negative 4. And if I factor out a 4, it's like I'm dividing by 4, and so that will be negative 1. So now those are 4 and 2x minus 1 are the two factors of the expression 8x minus 4. Now we're going to move on to example B. And our coefficients here are 6, 15, and our constant term is 24. So let's think. 6 and 24 could be divided by 2, but 15 cannot. However, 3 could divide 6, it could divide 15, and it could also divide 24. So that's what I'm going to use. And I will factor out the number 3. And if I take 6x and divide by 3, I will get 2x. If I take positive 15y and divide by 3, I will get 5y. And finally, if I take negative 24 and divide by 3, I will get negative 8. And those are the two for that expression. The next example, 4x minus 3y plus 19, 4 and 3 have no factors in common, and they also have different variables, so we can't factor that either. And also 19, it is a prime number. So what we could say here is that it is not possible to factor it, or we could refer to it as a prime polynomial. And we simply can't factor it. Example 7, now we have numbers, but also variables. And the key with variables is that you take the variable that they have in common, but with the one with the smallest exponent. So in this case, we know that 8 and 4 can both be divided by 4, so we will factor 4 out. And we have a variable that, even though they're not like terms, they both have x to the first power. So if I factor out 4x, we could think of 8x squared divided by 4x, and so that will equal to 2. And when you divide variables, you subtract the exponents, so this will be x to the first power, because 2 minus 1 is just a 1. Then we have negative 4x, so negative 4x, and we divide by 4x because we're factoring 4x. The answer to that will be negative 1, because we're dividing a negative and a positive. And that will be the answer for example 7, part A. Now moving on to part B, we have coefficients that happen to be even numbers. So we could say that all three numbers could be divided by 2, but that is not the greatest common factor. We could pick a number bigger than that, and that will be 4. So if we factor out a 4, we take 8x to the third power and divide by 4, so we will get 2x cubed. The next term is negative x squared, so if we take that and we divide by positive 4, we will get negative x squared. The next term will be positive 16 divided by positive 4, and that will be positive 4. And so those will be the factors of that example. Moving on to the next one, I want to point out something that sometimes before we start factoring, it is a good idea to see if there are any terms that could be combined. For that, they need to be like terms. So negative 3y plus 19y. Well, I'm going to start writing from left to right. 4xy plus 19 minus 3 is 16, so 16y. And now from there, we could try to factor the greatest common factor. And that will be 4, because 4 obviously can be divided by 4, and also 16. Now, they also contain this letter. They have y in common. So that will also be part of the GCF, the greatest common factor. Now, if we take this number, or this term, 4xy, and divide by 4y, we will get x. If we take positive 16y and we divide by 4y, we will get positive 4. And if you're not sure, there's nothing wrong with writing it down. Sixteen divided by 4 is 4. It is also important that you keep track of your signs, because you could be dealing with positive and negative numbers as you are factoring. So we're going to move on to the next page, and this is example 8, factor each expression. And we have here a trinomial. So we're going to see if there's something they all have in common. They can all be divided by 2, the coefficients, and they all contain x to the first power. We have x squared, and we also have x cubed. But if you think of this, that x to the third power is the same as x times x times x. X to the second power is x times x, and x is simply x. So the factor that they all have in common is 1x, or x to the first power, I should say. So what we're going to take out as our greatest common factor, our GCF, will be 2x. Now from there, we could start thinking of 6x to the third power divided by 2x. And that will give me 3x squared. Now if we take positive 4x squared and divide by 3x, I'm sorry, not 3x, but 2x, because that's our greatest common factor, 2x, we will obtain positive 2x. And then finally, we have 10x positive, and we divide by 2x because that is our GCF. And so that will give us positive 5. So that gives us the answer, the two factors of that expression. Now moving on to the next example. Our coefficients are 21, negative 18, and positive 7. All of those numbers could be divided by 3. So I'm going to factor out a 3, and also they all have an x in common. However, I'm going to choose the one with the smallest exponent because that means that they all have it, at least x squared. So we factor out 3x squared. And that will give us 21x to the fourth power. I'm going to write it up here, 21x to the fourth power divided by 3x squared, because that's what we're factoring. That will be 7x squared. Remember, we subtract the exponents of the variables. Then we have negative 18x to the third power, and we're factoring out a positive 3x squared. So the answer in this case will be negative 6 if we divide 18 over 3. And then after dividing our variables, we will get x to the first power. For the last term, we have 27x squared. And so 27x squared, if we factor out a 3x squared, the answer will be 9. And that will be positive 9. Okay, so now for example 8c, we're going to start working with factoring by grouping. And just like the name tells us, we are going to start by making two groups. And this is a very useful method when you have 4 terms. How do I know I have 4 terms? Because they're separated by the sign negative, positive, and negative. So we have 1, 2, 3, 4. So what we're going to do is make 2 groups. And we're going to group 4 and negative 2x squared. Then we're going to make a second group. Now, I'm not saying that they're multiplying. I'm just using the associative property, and all the terms are still adding to each other. I'm just simply making 2 groups by putting the parentheses, but not to imply multiplication. X squared, y cubed, and then we have a minus 2y cubed. Okay, now we're going to factor one group at a time. For this group, they do have a 2 in common. So we take out a 2, and then we will have, if we factor 2 from here, we get 2. And if we factor 2 from here, we will get negative x squared. Now for our next group, we could factor out they both have y to the third power in common. So we take that factor out, and we will get x squared minus 2. Now here, what we are looking for is for a greatest common factor that will be in the form of a binomial. You could see that our terms are similar, meaning we have an x squared, but here we have a negative, and here we have a positive one. Here we have a positive 2, and here we have a negative 2. So the way that I will fix this is by, I could do the following. Keep the first factor like it is, 2 times 2x, 2 minus x squared. And instead of factoring out a positive y to the third power, I will factor out a negative y to the third power. Why would I do that? Well, because if I do that, that would change the signs of this factor to the opposite signs. In other words, negative x squared and positive 2. Now, those two factors that are in parentheses, which we call binomials, are identical. We're just going to change the order. So in this case, we have 2, and let's write it, let's keep that one as 2 minus x squared. For our other factor, we have minus y cubed, and then inside that parentheses, I'm going to write the same terms, but I'm going to reverse the order. So I'm going to write positive 2 first, and then negative x squared. Now, it is pretty obvious that that factor is the one that both terms have in common. Now, I'm talking about having only two terms because this is one term and this is my other term. And so what they have in common is a binomial, not just a coefficient or a variable. It's a binomial, two terms. Binomial because they're divided by this negative sign. So that one is going to be my GCF. Now, if I was to factor this whole binomial, I would still have 2. So that will go here. Now, from the negative y to the third power times 2 minus x squared, if I factor out 2 minus x squared, I would still have negative y to the third power. And so that will be part of my second factor. So now I was able to factor a polynomial of 4 terms into the product of 2 binomials. And so that is what we call factoring by grouping. Now, example 9 is going to be also about factoring by grouping. And for this example, we could start by grouping 8 minus 4x squared. And then we will have a plus, because remember, we're not saying they're multiplying. They're still adding. So now I'm going to factor the GCF out of each group. So in this case, it will be 4. 8 divided by 4 is 2. And negative 4x squared divided by 4 is negative x squared. For my next group, I will factor xy. So if I factor xy from here, we have x to the third power y multiplied by y, and we're factoring xy. So the y's will cancel, but the x will still remain as x squared. So that will be what goes here. Now if we take this negative 2xy and we factor out xy, we will get negative 2. So that's what goes here. And so we have a similar situation as the other problem. So what we're going to do is scratch that out. And instead of factoring a positive xy, we will factor out a negative xy. So if we do that, and now imagine we have positive x to the third power times y, we factor out a negative xy, then we will get negative x squared. If we have negative from here, 2xy, and now we want to factor a negative xy, a negative divided by a negative will be positive. And so you can see that now if we were to just rearrange the terms, we will have something like this. 4 times 2 minus x squared minus xy times 2 minus x squared. I am just rearranging the terms here, and yes, it is possible because addition is commutative. You could change the order. And now the binomial that they have in common is obviously this one, 2 minus x squared. So that will be our first factor, 2 minus x squared. And if we factor that from here, we still have 4. If we factor that binomial from here, we still have negative xy. And so that will be the solution for example 9. So what I'm going to do is stop this video here before we move on to example 10, which is also a continuation of grouping. Or maybe we should just do that. Let's finish example 10. So again, we have 4 terms. And so we're going to use the factoring by grouping technique. So we'll start writing. We're going to group x to the third power plus 2x squared. Now, I want to point out that this does not always happen. Sometimes you have to rearrange the terms, or meaning like making the groups in a different way so that you can factor a GCF, a greatest common factor, from each group. And our second group is going to be, I'm going to put a plus or a positive sign there because although these two are negative, I just don't want to interfere with that right now. So I'm going to say negative 9x minus 18. Now you could put a negative out, and you have to make both your 9x and your 18 positive, which is also doable. So now if I factor something out of my first group, I could factor out x to the second power, because if they have a variable in common, you take the one with the smallest exponent. So that will be x squared. So we're going to factor x squared from here, and that will give me x. And if we factor x squared from here, we will get plus 2. Now for our second group, we notice that both of our terms are negative. So I'm just going to go ahead and factor out a negative number. So that would be negative 9. So if we factor negative 9 from here, from negative 9x, we will get positive x. If we factor negative 9 from negative 18, we will get positive 2. Remember, it's like we were dividing negative 18 divided by negative 9. So from here, we could say that the binomial in common, x plus 2, that will be our first factor. And the next factor is going to come from here and here. Now, this factor, it could be factored even further, the x squared minus 9. And that is something that we refer to as the difference of squares. Why? Because x squared is a perfect square, and so is 9. You could take the square root of 9 and get an integer. So, and difference because they're subtracting. So I could factor that as follows, x plus 2, and then I could say x, because we could get x squared by multiplying x times x, and the square root of 9 is 3, and what we do with when we factor difference of squares, we make a positive 3 and a negative 3 the second term for each factor. Now, to check that this is equivalent, I'm going to go ahead and multiply them. So if we multiply x times x, we get x squared. If we multiply x times negative 3, we get negative 3x. If we multiply positive 3 times x, we will get positive 3x. And if we multiply positive 3 times negative 9, we will get, positive 3 times negative 3, we will get negative 9. So now if we combine like terms here, they're opposites, so they equal to 0, or we say they do cancel. And so that becomes x squared minus 9. So see, this is the reverse process of factoring, just to show you that, yes, you can do that. So just to summarize this example 10, because I made a mess here. So we're going to say the complete factorization of it will be these 3 factors. So it will be x plus 2 times x plus 3 times x minus 3. And that is the end for that problem. So stop this video here. I'm going to upload it, and it will be section 1.4 part A. Then there will be a part B that will cover the last pages of this section.